Let me, dare I try to take a picture of it again. Okay. First of all, what kind of triangle is that? Any triangle inscribed in a semicircle is always a right triangle. By definition, this angle is 90 degrees. Okay? So, if we label this thing, we got, that's 5, that's 8.
Yeah. That means the QB would have to be 5 too, right?
I'm sorry, what?
That means QB would have to be 5 too, right?
No. Oh, did you say OB? Yeah.
Oh, yeah, sorry.
That's 5. Okay. So, here's the thing. A shaded region problem is 90% of the time going to be a subtraction problem.
Okay.
It wasn't with number 4, I think, because number 4 was just 3/4 of the circle, so it wasn't a subtraction problem. But these kind of problems, we don't have the geometry to know what this area is that I'm pointing at here. These shaded areas up here, we certainly know what the shaded area of the lower half of the circle is. It's half the area of the circle. But in terms of these shaded areas, we don't know how to do that. But what we do know how to do is calculate the area of that triangle, because it's a right triangle. And I also know how to calculate the area of the circle because they've given us the radius. So it's going to be, and this is the way I like to write it, it's the area of the circle minus the area of the triangle equals the area of the shaded region. Well, what's the area of the circle?
What's that?
What's the area of the circle?
25 pi.
Now we have to figure out the area of that triangle. Well, we know the base of the triangle is 8. Yeah. We don't really know. We got to solve for CB. In other words, the height of the triangle is CB, right?
Right.
How can we solve for that? We have a triangle, looks like this. That's 10 here, it's 8 there, and it's a right angle there. How do you solve for this side right there? There's 2 basic ways. The one way that always works is the Pythagorean theorem.
Yeah.
But most of the time, when they give you right triangles, they give you special right triangles. And the most special right triangle of all is a 3, 4, 5. Is this a multiple of a 3, 4, 5?
Yes.
Yeah, it is. This has to be 6. It's a 6, 8, 10.
Okay.
Now, what's the area of that triangle? 1/2 base times height.
That would be 24.
So that's the area of the triangle, and that's the answer. Now, because, find the exact area. That's why they didn't make this multiple choice and give you decimal problem or answers. The exact area is what I circled. 25 pi minus 24.
Yeah.
There's no answer that's more exact than that.
Okay.
And when they say give the exact, they mean leave it in terms of pi or square roots or whatever you have. You don't convert anything to decimal approximations.
Okay. Yeah, so just leave it in terms of pi.
Yes, exactly. And in this case, you got to leave it 25 pi minus 24 because it's a combination of numbers that have pi in them and numbers that don't.
Right.
But that's the proper answer. If they had multiple choice, that would be one of the answers.
Okay.
Okay.
Okay, cool.
What else?
Let's do number 4 above number 6.
I'm sorry, what?
Let's do problem above number 6, number 4.
Number 4 you want to do?
Yeah.
These are pretty easy. Because all you have to know is the general equation of a circle. What is the general equation of a circle?
I don't remember.
It's x minus h squared plus y minus k squared equals r squared, where h and k are the center and r is the radius. Very straightforward. Okay, so now looking at this equation they gave us, what is h?
5.
Nope. X minus h. If h was 5, it would say x minus 5. It doesn't. It says x plus 5. So what's h got to be?
-5?
Uh-huh. What's k?
K is going to be -1.
No. It's y minus k.
+1?
Uh-huh. Make sure you understand why.
Yeah.
Y minus k would be y minus 1. And h, x minus a minus 5 would turn into x plus 5, which is what we have. Okay? And what finally is r?
R is, like R squared.
R squared is 16. What's r?
Yeah, I put 16 is R. If you just had like R, then you have it squared, it has to be 4 squared.
R is 4, not 4 squared.
Oh, yeah.
Remember, this is r squared. Okay, so r squared is what's equal to 16. That makes r equal to 4. Okay, so which answer is it?
Let's see. B.
What'd you say?
B.
Yep. That one right there. Okay. What next, Ben?
Number 2.
I think I can do that. Yeah, if I blow it up a little bit, I can read it. Okay. So AB is 15, DB is 17. What's BC?
15?
Uh-huh. Because they're both tangent, they're equal. And they want the perimeter of that figure. A, B, C, D. So we need to figure out AD and DC, the radius. What is this angle right here?
The right angle?
It is. In other words, whenever a line is tangent to a circle, at the point of tangency, if you draw a radius, it makes a right angle with your tangent. So that's a right angle, and this is also a right angle by the same exact reasoning. Okay? Well, if that's a right angle, let's draw that triangle. We'll just draw it outside. That's just this triangle here. And that's a 15, 17. You know what this measurement is? You know how to do it using the Pythagorean theorem?
Yeah, I could, yeah.
Go ahead, do it then. I want to make sure you can do it. The quick way to do it, when you're solving for one of the short sides of a right triangle, the quick way is it's equal to the square root of the hypotenuse squared minus the other side squared. And you're going to find that's equal to 8. Okay? Now, you're going to have to solve so many right triangles over the next couple years that it's really worth remembering exactly how to do it quickly. In other words, you don't really want to start here because that involves a whole lot of math, right? In other words, if I'm solving for A or B, then I've got C squared minus B squared equals A squared. Now I got to take the square root of both sides, so I get A is the square root of C squared minus B squared. Remember this from the start. You don't want to have to go back to that every time. And I say that because there's only two difficulties when solving a right triangle, and that's if you're solving for the hypotenuse, then it's the square root of the short side squared plus the other short side squared. If you're solving for one of the short sides, it's always the square root of the hypotenuse squared minus the other short side squared. So these are the only two you have to memorize, depending on whether you're solving for the hypotenuse or one of the short sides. If it's one of the short sides, it's always that. It's the square root. They all start out with the word square root, in case. Okay? So when you're solving a right triangle, the first words out of your mouth should be square root of. Now, it might be a perfect square number. You know, it might be 64, square root of 64, which was 8, but it's still the square root of something. Always. Because so many people forget the square root that I can't emphasize enough to include it. Now, if that's 8, and it is, because that's one of your basic Pythagorean perfect triangles, what's the perimeter of that figure?
46.
Correct. Notice we didn't use, hold on one second, I smell something burning, Ben. I need to check downstairs, 1 second. I guess somebody's probably barbecuing outside, and that's what I'm picking up. It smells good. I haven't had dinner. All right, which one do you want to do next?
Let's Number 7.
You know how to complete the square?
Yeah, I've done a little bit, but I have done it.
Okay. Give me again what the general equation of a circle is.
X minus h
Squared.
plus y minus k squared equals r squared.
Okay. What we have to do is put this polynomial into this format. And there's really only one way to do it, and that's by completing the square. Okay? 2 steps. I'm going to move the 77 over to the other side first, and then I'm going to group the x terms together and the y terms together, giving me this. X squared plus 14x, leave room to complete the square, plus y squared minus 16y, leave room to complete the square, equals minus 77. Okay? So far I got exactly what I started with. And that's the way you want to do these problems. You want to make sure as you go from step to step that you do not change that equation. So all I got to do is get it in this format. Well, I'm going to do that by completing the square. So complete the square on the left side, or in the x part. How do you complete the square?
Is it the square root of it?
Take half of the coefficient of the x and square it. Well, what's half of 14? 7. 7 squared is 49. I just added 49 to the left side of the equation. I got to add 49 to the right to balance it. Now it's exactly the same. I still got the same. What's that?
It's starting to come back a little bit.
Okay. Complete the square in the y term. And you're always adding, never subtracting. Because even if that's a negative number, when you square it, it turns positive.
Okay. That'd be plus 64.
I got to add 64 to the right side of the equation. Now, the fact that I completed the square allows me to write that as a linear term squared. In other words, that becomes x plus 7, whatever you got when you divided that by 2, quantity squared. This becomes what?
Let's see, y, plus 8.
It's minus. It maintains the sign of the middle term.
Minus 8.
In other words, you got to make sure that when you square this, you get this. If it was plus 8, you'd have a plus 16y there. Okay, and then the right side, I got 113 minus 77, what is that, 36?
Yeah.
Bingo. Here's what I got. X plus 7 squared plus y minus 8 squared equals 6 squared, which is 36. So tell me what the center and the radius of the circle are. Which answer?
B.
Yep. Where did they get this 8.8? How did you get 8.8 out of that?
I have no idea.
So really, the only thing we had to solve for was the radius. Once we solved for the radius, they only had one answer that had that radius.
Yeah, that's pretty easy.
Well, if you notice stuff like that, sometimes it can make it quite a bit easier.
Okay. But they make those problems or like the other answers they give you besides the one that's correct? How do they go about doing that?
I have no idea. You mean where they come up with these other answers?
Yeah.
Yeah, I don't know. I really don't. I suppose they have something to do, in other words, there's a 14 and a minus 16 in a couple of them. Maybe they get them from there, thinking people will guess those because they're looking at those numbers. Oh, and I guess the 8.8 is the square root of 77. That's what 8.8 is.
Okay.
But of course, when I move the 77 to the other side, it becomes minus 77, and only turns positive when you do all that completing the square and balance it out on the other side. Do we end up with a positive number over there? So what next, Ben?
Let's do 9.
Okay. I think, here, let me move 9 up here. That's as high as I'm moving it. Find each measure. All right, the measurement of ML. When they give you that kind of terminology, that's not arc length. That's the degree measurement of that arc. There's two different measurements of an arc. There's the degree measurement, and then there's the length of that thing. Okay? So, what's that?
Is that 118?
Yes. Because it's twice that.
Yeah.
In other words, when the vertex of this angle comes from the circumference, then the angle that it cuts out is always twice what this angle is. If it comes from the center, it's always the same. In other words, if I were to draw that, that's 118 degrees right there. You with me?
Yeah.
That's the two most important things to know about these. Is if it comes from the center, it's the same. If it comes from the edge, it's twice. Now, let's do JM since they're going to ask about it eventually. Plus we can, oh, no, we can't do it yet. Can't do it yet.
Yeah, we can see first.
Yeah, let's go in the order that they request. There must be a rhyme or reason for them doing it like that. So what's the measurement of JLK? This angle right there.
Is it 76 degrees?
67, I believe. You wanted half of one.
Yeah, 36, 7, yeah.
Okay. So this is 118. This is 67. And then they want JLM, which is this angle.
Okay.
What's that going to be?
Let's see. That's gonna be. Hold on, let me do that.
Remember, this is a right angle. That's a right triangle because it's inscribed inside of a semicircle. When you inscribe semicircles with right triangle or with triangles, they're always right triangles. I cannot draw a triangle inside of a semicircle without making it a right triangle. Doesn't matter how I draw it. I can draw it like that. I can draw it like that. These are always right angles. Okay?
31 degrees.
Okay, good. So that's 31. And then finally the measurement of JM is what?
That is 62.
Mm-hmm. And that's it. And we could figure out what the measurement of KL is by adding up the measurements of these other three and subtracting from 360.
Yeah.
And that would be this measurement here. I'm surprised they didn't ask it. That would have been the toughest thing to figure out the whole way. You would almost have to figure out these four things before you could figure out the measurement of KL.
Yeah.
Okay, what next?
I'm not sure if they're asking in number 8.
Okay, let's have a look at number 8. All right, this involves a geometry formula also.
Oh, they want X. Oh, okay.
That's a right triangle, right?
Yeah.
In other words, because X is a tangent line, even though they don't say so, they imply that. Well, that makes that a right triangle. So solve for the short side. What's the quick way to solve for X? X equal what?
Yeah, it's your shortcut of,
Always begins with square root of.
yeah.
And since I'm solving for the short side, there's subtraction going on.
So, yeah, hypotenuse minus.
Hypotenuse squared minus the other short side squared. That's the quick way of doing it, which is 121 minus 64, which is the square root of 57. That's what X is, square root of 57.
Yeah, 7.5.
Yeah, square root of 57.
Yeah.
I don't like decimal answers, in case you haven't figured that out.
Okay. Yeah.
In other words, once you get past geometry, you're not ever going to be converting those things to decimals. The answer is root 57. It's only up through geometry where they have you convert everything to decimals. Once you get into Algebra 2, you'll stop doing it, and beyond Algebra 2, you'll never do it, because they care about precision. And if I convert that square root of 57 to a number, it's not precise. I'm rounding it off, necessarily. It's an irrational number. So if I want to be exact, I got to put square root of 57, which actually I can reduce. Can't I? No, maybe not. No. No, that's 3 times 19, both of which are prime. So, yeah, no, I can't simplify it. No, the key is just realizing that a tangent line makes a right triangle, or makes a right angle. Now, oh, we might actually have this problem wrong. You were correct, and you weren't quite sure what they were asking. The question, and I suspect the correct answer, is 11 is the measurement from there to there. Which makes that 8, because all radii are equal in a circle. So really the triangle we're solving is 19, 8. But I don't know that for sure. I don't know that that 11 means the measurement where I've got it marked, or whether it means the measurement all the way to the center of the circle.
Yeah, they didn't mark that very well.
No, they didn't. And that needs to be clarified. The only reason I think that it's 19 is because there is a formula that applies here. Not the Pythagorean formula either. There's a different formula involving tangent lines and stuff, and let's see, if I remember right, God, I'd have to look it up to be exact, but we don't really need the formula here, because we know that all radii are equal, so I know that's 8. So it's an 8, 19 right triangle, and then I would solve for a different x. If that's what they mean. If they mean that that 11 is all the way to the center, then it's an 8, 11 right triangle. either one is easy enough to solve for x. We just need to know what they mean. But the more I look at it, the more I think they mean this. In other words, that hypotenuse is 19.
Yeah. I hate when they don't say those correctly.
And it has to do merely with the fact that there's a part of geometry that deals with this kind of a situation, and there's a special formula for that. I can't remember exactly what it is, but we don't need it because I can use the Pythagorean formula to solve it. Which, like most math, there's always 3 or 4 ways to solve any given problem. In fact, they say that the difference between the education system in the United States and Asia is, and you know, Asia outscores us. We're like 26th in the world, and Asia is the top 5 in the world. And the primary difference in the way that we teach math is in the United States we spend an hour doing 20 problems. In Asia, they spend that hour doing 5 problems from 4 different angles. And I don't mean angle, I mean from 4 different perspectives. Well, and I can see why that's true. In other words, if I can show you 3 different ways to solve that, number 8, you're better off. You have a better understanding of it than if we just did 20 problems like this and I used the Pythagorean theorem on all 20 of them.
Yeah, that's a good point.
Yeah, no, it makes a lot of sense to me. And in fact, once I read that a couple years ago, it kind of changed the way I tutor. I tended to be a 20 problems per hour guy, and I started tutoring, well, we just look at 4 or 5 problems and we'll look at them from a different perspective, each one of them.
Interesting. Yeah, that's pretty cool.
Yeah. So, anyway, Benjamin, I'm going to let you go.
Alrighty.
I got another session, but I'm glad we got back on and that I figured out how to handle it when my thing locks up like that.
Yeah.
Always got a reboot. Yeah, there's nothing that replaces a reboot. Yes. Well, it doesn't take so long with Windows 10. When I had Windows Vista, it took like 7 or 8 minutes to reboot. With Windows 10, I can reboot in 2 minutes and be back online pretty much. So, yeah. All right, Ben. Good night. Have a good rest of your week.
I will. You too.
Bye-bye.